Hello, my name is James MacKeith. I'm a developer with InterSystems, and I'd like to show you a new feature that's been added to the Iris product stack. It's available to test now. As of August 2025, it's in the latest preview for Iris and Iris for Health, and then it's planned for the released 2025.3. The feature is one that allows us to be selective about the message that is dequeued based upon an identifier that is calculated from the message contents using a method or transformation that you as the interface developer create. This allows for maintaining FIFO for a given message feed where there is a dependency for the FIFO for a certain message grouping, not for the whole stream. So for example, all those messages with for a given patient need to be in order, but the patient messages aren't dependent upon another patient. This, by the way, is not just limited to HL7 and health messages. It's available to any message type that we have and can be processed in an interface. But let's start off by looking at just an HL7 interface. There's new settings for business process and business operations, which is optional. That is a setting for a transformation that you create that is, if it's defined, the host item that is queuing to this one will run that transformation on the target, on its message body, in order to create an identifier. So here's one for an HL7. We specify the target type of ends.q.fifo message group.data. There is going to be documentation attached with this demonstration. And the intention is to set the target.identifier based upon the contents of the body. So here I've just done a generic one looking through to look for the PID and assign it as the identifier. So now, if that is defined on the host, when a message is queued to it, as part of the queuing process, the transformation is run, the identifier is calculated, and is associated and stored with that message header in new properties. And then that will stay with the session until what we're calling a completion host, the identifier. We're finished with that particular message for that identifier, and we can move on to the next one. So that's why there's another setting called group completion host. If we don't set it, it defaults to being that host. So it's just as soon as this router is finished with that identifier, it can move on to the next one with the same identifier. Here I've taken a particular rule, and to simulate it, I put a half-second delay in the rule, and it's going to generate 100 messages. So obviously when I first ran it, it took 50 seconds to run 100. So now if I started here, and while it's running, we can have a look at it and what's going on. We'll look at the queue data. Now what we see, if we look at the metadata, we see there's the data in the queue. There's some extra zero node metadata entries. There's a thing that's where key FMG DTL that's pointing to the transformation, so that the host queuing up can say, hey, this is defined, I've got to run this transformation. And if it's not defined, it doesn't, it's just going to behave as it did before, although it is also possible for the host in custom code that's sending to this to run it with the macros. I'll show that later on in the demonstration. It's also documented. In pipeline is where we are storing the information that for this particular identifier, number one, is in progress. So now the dequeuing process, what happens is it will, as it dequeues, without the FIFO message grouping feature, as we know, it dequeues, it owns that message, and then it has to have that message that's at the top of the queue. And the next job will take the next one. Now what is happening is the code says, there is, this message has defined with it an identifier. And therefore, if we go and look here at the messages that are going through, it says, there's an identifier. We've got these extra properties, complex object, FIFO message group, which also contains some extra information that we know the starting queue and the start header that gets set as part of the queuing process. And that it says, there is an identifier. We cannot dequeue if there is one already in the pipeline. So just a very straight up dollar data, is there one already with this identifier? If there is, let's move on to the next one. So if we look at that, what have we got for the time it took? It should be half the time, and it is 25 seconds. So let's look at a bit more of a complicated one, and I'm going to demonstrate it with a workflow where we are going to be within the business process BPL. We're actually going to be we're assigning it here. So we're not using a transformation on the target. The sender is, and it's going to be in the documentation about setting what one needs to set for these values. Now, there are some macros, helper macros for BPL. So this is just, all I'm doing simply here is I'm assigning the identifier based upon the message coming in. And I'm also going to talk about the dependencies, where we can say, it's also dependent, we've worked out it's dependent upon a different identifier. Okay, so this is, obviously I'm just using a straight up pure iris class object. It's not health related, but just demonstrating here we do the same. So what I've sent in 9 messages into this production. And what's going to happen is the workflow, until we do the manual, is the bit that's going to do the complete, that's going to say, yeah, we can move on to the next, right? Simulating, a long-running router or BPL. So if we look, we've got 2 messages that we're actively working on. The subject and the group identifier I've set for simplicity just to be the same. Right? So we've got, one's got a group identifier B and one's got a group identifier A. If we look at the queues, we look at the top of the queue, we see at the bottom some information, and it's telling us, it's able to work out that it's waiting on the release of 20, which is the message header. If we look in the, right, so it's waiting on this one to be complete, because the completion host has been set to be it. If we look at it, it's self. So it's got to come back all the way back, because we're not defining it in the BPL as being later on. We could have done it with an operation. So now if I complete A, we see that the message trace, that's come back. The queue's gone down to 6. And the workflow, the other A has appeared. Now, we do have a safety feature, APIs. If something's getting stuck and it's not clearing, we do have if we look at this here, we've got an API that can be called store procedure or programmatically, so to be able to release the whole. Now, this hasn't done anything as a different namespace, but once passing it in the header ID, that will then clear up the pipeline entry and then signal that the job can move on to the next one. Now, if we look at this, we've got A and B. We look at the queues. We've got the first 4. It's a group B. It's still waiting on B. It's not going to be processed. So we can complete A. and we don't see any more that have come through. Well, the first one, that was a B that's waiting on the B. Well, what's number 5? 5 is an A. Well, there aren't any A's currently that are being worked on, but this extended feature of dependencies, programmatically, we've worked out in our code, in the business process that was there, hey, A now has to wait on any B's that went ahead of it. Maybe some mergers that were, taking place. So now this one's not going to go. If we look at now, we can complete the B, and we then look at the Q's. We now got A is still waiting. There aren't any A's, it's waiting on the B's. So let's complete the B. And now A comes through. We can look at the global data. In here, we're just going to go and change the namespace to the FMG one. And it's Q view. And then here we can see, if we come down here, the in pipeline. So this is the one we're interested in, which is responsible for, and then we see the in pipeline that the A, we need to know, so that's the message header ID and then the Q entry, because what's also important is that we have to be able to put things back where they were in the event of a failover, an unexpected and unplanned or a forced production down, to know that things go back in the order. So now let's complete this. Oh, if we look at what's in the queue, it should be 4. Why is that hasn't gone in? This one hasn't gone in because we've got a safety identifier. There's a macro for a document called _single thread override. Say an error went in the if we detect an error, an unexpected error in the data transformation, or this can also be used programmatically, it says, okay, no, let's not go any further in the queue. Okay? Even if there's the multiple ones, you just sit there waiting. And now we've gone into single, sort of, not quite limp home mode, but it's like we're just going to do one at a time until it's no longer identify _ single thread override. And if we find one in a queue after another one, we're not, likewise, it's going to have that safety feature. Now, what we can do here, just to show another element about it, I'm just going to jump in between the two different UIs, is there is some variables at the moment where for interest to see what's going on, how much does it make sense, we're creating this data. At the moment, we're just storing it in the process so we can look at it here. We're not trying to pull it out. But the idea is we can see here what we're looking at is skipped. How many times has it looked for a message and said, oh, I can't take anything? Right? So we bump up the skipped. And it shows we're getting what's the cost of this skipping? How long is it taking? Right? Because the idea is, we've been called 15 times, we skipped. How many times have we been successful? And then the whole point is the signaling that we don't want to lose. When we release one, we then signal the queue again, say, okay, go and look again to see whether you can do anything. And very efficient. So then we come through, we'll just complete this. And there is a single thread override. We look at the queues, and this one is a normal one, but it can't go on because we've got an _ single thread override in process. Basically, we're saying we don't know what the identifier is for that one. It could be a C, so don't release it. So this is a safety feature. And then as we go through completing these, we work our way through the queue, and as we see the 8. Again, I've thrown in another single thread override, so it wouldn't go on to the next one. And then we're allowed to, if we look at the queue here, and then the last one is a C, and it comes through. So hopefully that's given you an indication of what this new feature is. Like I said, it's available to try now. Please do download the latest preview, and it's on business processes, business operations. Obviously, another angle is on an operation where you want to fan out, where you've got say a TCP-based operation that can fan out. The downstream system can have multiple connections. You can apply the group calculation on the operation. So instead of having to have multiple names and route them to different ones based upon an identifier, now the identifier calculation could be on that operation, and then pool size of 5 or 6 or 7, you can vary the pool size, and then it'll go through. We're not taking, the critical thing is, we're not taking jobs that are waiting out of the queue global. We go over them. So we're trying to reduce the overhead of managing different links so that the safety feature of where something goes wrong, we're going back to where we were. We're putting the queue back in the right order. All right, well, thanks for that. Obviously, I'll take any questions and look forward to discussions on the community. Thank you so much.